Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Susie, and we are here in Bakersfield. You can call us at 636-4357. That's toll free. If you're in San Luis Obispo, you can call 1-866-636-6284. You can also email us at dothemath@kern.org, or you can watch online at dothemathonline.net. We're also on social media, Facebook, Instagram, Twitter, and YouTube.
All right, well, you just whispered into my ear as a reminder, today is the last day of live broadcasting for Do the Math this season. So today, the 20th, the spring is now here also.
Right.
So everything is now turning, changing, and things like that. So spring is here, and today is the last day for Do the Math for live broadcasting for this season. There, of course, will be opportunities to view the program online as well as on KETN. But today is the final day of live broadcasting, and because of that, we have a very special guest in studio with us today. We'll meet that young lady in a few moments. We'll be going out to learn a little bit about the steel business.
Cool.
But before we do any of that, let's first take a look at today's Math in the News. So I found this story interesting. It was interesting facts about your body. And the largest organ, we've done this on Do the Math before, is your skin.
Right.
Right? It takes up about 15% of your weight. But I found something also interesting about the nose. How many different smells do you think the nostrils can detect?
I kind of thought it was unlimited because it's so closely related to taste.
But they actually gave it a number.
Okay.
Not an exact number, but in the trillions.
Oh.
Did you think it was that high?
Well, yeah, that's pretty close to unlimited.
Yeah. So anyway, there are a bunch of noses we have up on the screen right here. And that's the reason why we brought this story up. But then we talk about place value since we're talking about trillions. So we can see that in the place value chart, each one of these has 3 spots. And each one of those is a period. So the ones, right, goes up to 100. Then we have thousands, millions, billions, and trillions. And up here, this is where the nose finally comes into how many different scents they can detect. So, in studio with us right now to help us out with this, we have Mallory. And how are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to school at Lost Hills, and I'm in 3rd grade.
So you go to school at Lost Hills and you're in 3rd grade, and you are probably, I would have to say, the youngest guest that we have had on Do the Math. So that's why we wanted you to come on the final day. You are the youngest person that we've had on Do the Math this season. You excited about that? Yeah, why not? She's like, yeah, I'm the youngest kid on here. All right. So place value. You're in 3rd grade, and you've learned a little bit about place value, right? You know what the ones, tens, and hundreds are? Like if you wanted to say this number right here, these 3 numbers, what would you say? If I just had 194. Because if I just had 4, I would just say 4, right?
194.
194, right? What if I just wanted the 9 and the 4? What would I say?
94.
94, right? So let's try this. Let's go to the 8. if we had 8194, what would that be?
8,194.
There you go. So you've got this, right? So you've done this in class before. Can you read this whole number that is on here right now?
How many millions?
So go to the millions first, right? So how many millions?
5.
Okay, so there's 5 million. Now how many thousands? See, because the thousands takes up all three of these. So put that, that, and that. These three numbers all together and you get what? So this is going to be 278.
5,278 and 194.
Right.
Very
So
good.
5,278,000, right? Because these are all thousands, 194. All right. So you got the hang of this a little bit? All right, because here comes the big test right now. Now we have all of these places again, right? We have the ones, the tens, the hundreds, right? But there are no numbers up there, are there? So what I'd like you to do is go over to the board, grab a marker. Yeah, go on over. Susie will go over with you. And first of all, down at the bottom three, the ones, the tens, and the hundreds, put any number you like in any of those spots. So now read that number for me.
243.
Just 243, right? Add another number in the thousands place. So read that whole number now.
3,243.
Add another number. Now read it.
43,243.
What do you think I want you to do now? Add another number. Now read the number.
643,243.
Add another number. Did you think your nose could smell all these different smells? You can erase it if you want to make it.
Yeah, here, I'll help you. Oh, you did it, yeah, okay. Well, good.
All right, so now read that number.
So 7 million.
7,643,243.
You getting the hang of it? Add one more number. So now instead of 7 million, how many million do you have?
17,643,243.
You want to try another one? Go ahead, try another one.
Go ahead.
217 million and 643,243.
All right,
Very good.
you're doing well. How about we push it and go one more number? All right, so now you're in billions. So how many billions are there?
3,217,643,243.
All right. One more. So instead of 3 billion, how many billion do you have?
23,217,643,243.
All right. How about we let Susie put a number up?
Okay.
Now, should we make Susie read it, or do you want to keep reading them?
I'll keep reading it.
You want to keep reading them? All right, try this one now. Instead of 23 billion, how many billion do you have?
923,217,643,243.
I'm
And
impressed.
your nose can smell even more than that. So put one more number so we finally get into the trillions. Yeah, that's a good number to put up there. All right, so now how many trillions do we have?
8,923,217,643,243.
Well, that's a pretty good job right there, Mallory. Nicely done on that. I can probably guarantee you that you have now said the largest number of any third grader in your entire school.
Yep.
So nicely done, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. Come on over here real quick, Mallory. I would like to ask you, first of all, how third grade is going.
It's going really good.
It's going really good. What do you like about third grade?
That I get to do math and I get to read chapter books.
So, all right, so you're getting to do a little bit more math, and you like the chapter books now, right? Is there one that you're reading or you've already completed?
I'm reading the Dragon Masters.
So you like that? Well, good. Well, that was a pretty good first problem for you to work on. Did you ever think you were going to have to go up to the trillions today? Nah, that was something bonus for you right there. Anyway, we do have our first opportunity. We're going to go out and about, learn a little bit about steel with Devin.
Hey, thanks a lot, Mike. Good afternoon, everybody. Welcome. We're coming at you live from Merjil Steel Fabrication here in Bakersfield. We're going to take a look at the process of making metal come together and look at some fascinating projects coming around here in town, thanks to the folks here. We're going to talk today with Eddie Merjil with Merjil Steel. Eddie, good to see you today.
Oh, good to see you too. Thanks.
So, tell us a little bit about the company. What is Merjil Steel Fabrication all about?
Well, Merjil Steel Fabrications, we've been in business since 2007. We're a steel fabricator. Structural steel, miscellaneous metals, architectural metals, even and wrought iron. Anything and everything out of metal.
So your work involves mainly not just processing the metal that you'll work with, but fabricating it, shaping it so that it can be used in any variety of projects across town.
Yes. We take the raw materials that we purchase from steel suppliers, we fabricate. We fabricate parts, base plates, bend, cut, punch, and then fit, and then weld.
So we talk about the welding process and the fitting process. There is a variety of tools and machinery that are involved in the process, and a lot of them are being employed actively as we speak. So, okay, would you be able to kind of walk us through what we kind of have around laid out?
Yeah,
right here on the
we have
workshop?
here, we have columns actually for a canopy and an awning. It's actually going in to the ROC Center here in South Bakersfield. What we have is hollow structural steel, tube steel, and we have plate components that have been fabricated, drilled, and then, of course, attached, tacked, and currently being welded to the top of the columns.
So these plates here, this is where the welding comes in, and you've got these plates that are being attached because we're going to be attaching a beam to these in the installation site. There's going to be an overhang that people are going to be able to walk under, connecting a couple of buildings, from what I understand.
That's correct. It's going between two buildings. This canopy is going to end up, there's going to end up being 38 of these columns underneath this awning. And the awning is going to be a Z-shaped pattern, and it's going to have actually 12-foot clearance underneath when it's all said and done.
Now this process requires a lot of protection. What kind of temperatures are necessary to weld these pieces together?
Well, the weld wire is currently being melted at approximately 1750 degrees. Of course, what you're doing in the process is melting the plate and the tube steel together while adding filler material, which is going to establish the joint and the strength of the weld depending on the size of the weld that's required. And the size of welds are all part of the design criteria in being, as far as an engineer designing the size of weld it's going to take to attach that component and keep the strength within the columns.
Now, looking at some of the other projects they have working on here, one of the fascinating things is sometimes a singular spot weld will do the job, but for other components it'll be a complete a fixation here. So, what determines what kind of weld is going to be necessary for some of the components you have?
The engineering involved, depending on what they're trying to accomplish with the weld. If it's a full pin, this is a hinge on a trash enclosure gate. The hinge will need to be fully welded to support the gate. The angle iron is for aesthetic, so it's only being partially welded.
So this is more decorative, so it doesn't need the same type of structure, whereas this is going to hold most of the weight of the gate and a lot of the force as it swings open and shut during the course of its life.
Correct.
So you're going to need a lot more support there. And you mentioned the engineering part. There is a lot that goes into the design so that you know exactly what weld is going to take place where before you even get to the materials.
Yeah, absolutely, absolutely. And the welds are designed. Even the structure itself, when you take this tube steel, it's being assembled. Well, this weld's been engineered to establish what it's going to take to keep this gate together. That particular weld, needless to say, is ground down because of visual. It's architectural, aesthetic, an approach. So they take that into consideration when they do design the welds.
And that process takes place not just here in the workshop, but back in the office as well. So when we come back for our next segment, we're going to look a little bit at that planning process. We're going to roll out some blueprints and see what it looks like before we get to see what it looks like. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, guys. We'll definitely be looking forward to more of speaking with Eddie and the goings on over at Merjil Steel and how they get all that stuff together. You want to work with steel someday, maybe? Never know, huh? You never know what can happen. Well, I know what's going to happen right now. It's time for you to work on some more math. Are you ready? Let's take a look at the problem. This is one of the problems that Mallory brought in, and she needs to figure out what the area is of that shaded in rectangle. So why don't you head on over to the board. Susie's got a copy of that drawn up on the board, so you girls can explain kind of how you're going to go about solving this, okay?
Does this give you a clue? Mm-hmm. What does it tell you?
It gives me a clue that this is 6 and this is 6.
That is correct. Go ahead and write the 6 there, okay? Very good. And then, can this help you figure out something else?
Mm-hmm. It
Which
can
one?
help me figure out what this is.
You want me to reach that for you? So, what do you think that is?
I think it's 7 because 6 times 7 equals 42.
Well, you even had the reasoning. All right, so do we know anything else now? Kind of like a detective, huh?
Yeah. We know that since 7 goes up here, we know that 7 goes down here because that gives you a clue that goes down here.
That's correct. And then I bet you know something else.
Yeah, I know that 5 goes here because 7 times 5 equals 35.
Excellent. What else do you know?
I know that 5 is here because we saw that 5 is right there.
Mm-hmm.
So 5 goes there.
Good. And can you figure out this one?
I can figure out that this one's 4 because 5 times 4 equals 20.
Good.
And then that gives me a clue that 4 it goes up there.
Okay. Whoa. Okay, and so then what goes in here?
I think 24 goes in there.
Let's use the red for that one. Can you reach it? Yep, I certainly agree. 6 times 4 is 24 inches squared. Have you done inches squared before, or do you say square inches?
We say square inches.
Okay, yeah, that's kind of a junior high thing.
Now,
have
hold
inches
on,
squared.
ladies. Before you move on, I need that labeled correctly.
Okay. Can you, here, look, inches squared. That's a little exponent of 2, and you haven't seen that yet, have you? Okay, but like you said, you say square inches, and that is correct as well. Okay?
There you go. Now that's nicely done. All right, so Mallory brought in a couple of other cards. So let's take a look at these cards, and we're just going to discuss them right now. So we can see them up on the monitor, okay? True or false? Just like a game show for you, huh? Here we go. 74 plus 80 is equal to 80 plus 74. Do you think that's true or false?
I think it's true because they're the same numbers but switched around.
So they're the same numbers, but they're just in different places, right? Are you positive of that? So you no doubt that that's true. Mm-hmm. Is there any way that you could prove it?
Well, I could add them.
You could add them. What's 8 and 7?
15.
So 80 and 70 is 150, right? And then we have 4 more, right? So down at the bottom, what's 8 and 7?
15.
And we know they're in 10, so that's 150. And how many more does it have?
4.
So it is 154, isn't it? All right, you're 1 for 1, young lady. Here we go. On to your next question. Which one's larger, A or B?
I think it's B.
You think it's B? Why do you think B?
Because just because A looks bigger, there could still B could still be bigger just because that can go to 100 and something.
Okay. So you know that B is going to be over 100. Because how do you know that already?
Because 50 plus 50 is over 100 and
Good, so you know that that's over 100. How many over 100 is it? Because they might be very close.
B is 105.
Perfect, so it's 105. Now what about A?
A is 103.
Well, that was pretty quick. How'd you get that?
Well, because I added it in my head.
You added it in your head? What did you add in your head?
I added 63 plus 40.
So you went 63 and went 40 more, so you went 63, 64, 65, 66, 67, 68, 60. Well, then how did you do it?
I added them.
Well, how?
I put 60 at the top and 40 at the bottom, then I added them both.
Oh, so you added 60 and 40 first, and then you got 100, and then you threw the other 3 on there. So what was your guess at the beginning of this whole thing, A or B?
B.
It was B, and you are now, young lady, 2 for 2, so well done on that. Hey, we do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this. Today we're at Belridge Elementary School, home of the Panthers, and we're here to... And once again, we're back at Belridge Elementary School. We've got some students, and we are working on greatest common factor and least common multiple. So, once again, if we think about a multiple, okay, it's by counting 6, 12, 18, 24, 30, right? You guys remember all that? Okay. Take a look at the problem that I've put down between the both of you, all right? So, do me a favor if you can read that out loud.
When the pennies are put in groups of 2, there's only 1 penny left over. When they are put in groups of 3, 5, and 6, there's also 1 penny left over. But when they are put in groups of 7, there are no pennies left over. How many pennies could there be?
Okay, so you need to know your multiplication, right? And you need to know that, once again, it says if they're in groups of 2, there's 1 left over. Okay? If they're in groups of 3, 5, and 6, there's also 1 left over. But if they're in groups of 7, there are none left over. So you have a 100 chart to work on if you need to like cross out some numbers and stuff as you're going through this. You can work on it on your own, or you can work with the person next to you and see if you can come up with how many pennies are left. You guys ready? Only one question you have to find out, how many pennies there are. Go. So does anybody have an idea of where you would like to start? Does anybody have a number to try? What do you think?
21.
Try 21. All right, perfect. So let's try 21, okay? Now, if they're put in groups of 2, if you have 21, can you put them in groups of 2 and have 1 left over? Yes, because you'll have how many groups?
2.
You'll have 10 groups, right? 10 groups of 2, and there will be 1 left over. So 21 works so far. Now, what about if they're in groups of 3? If you put 21 in groups of 3, will there be any left over? No, because it works out even, right? So 21 won't work. Who's going to try the next number? What's another number? You all know multiples of 7, right? Okay, what's another multiple of 7 besides 21?
35.
35, all right? Let's try 35. Now, if you take 35 and you put them in groups of 2, will you have 1 left over? If you count by 2s, can you get to 34? Yeah, And how many are going to be left over from 35? 1. Okay, so far it works. Now what about 3s? If you count by 3s, how close to 35 can you get? What's 3 times 10? 30. What's the next 3? 33. What's the next one? 36. Okay, so if we put them in 35, if we have 35 and we put them in groups of 3, will there be 1 left over? There'll be 2 left over, won't there? Okay, so 35 is not going to work. All right? What's the highest multiple of 7 you can think of that's on that chart? What's 7 times 10?
70.
Is there a number higher than 70 that 7 will go into?
77.
Which one? You guys are in 7th and 8th grade, right? Give me a number higher than 70. What's 7 times 11?
77.
77. What's the next highest number? Count by 7s. What's the next highest number after 77?
84.
84. What's the next highest number?
91.
91. What's the next highest number?
88.
I'm going to give you a clue. It's one of the last 2 numbers. It's either 91 or 98. You try it. Let's see which one of you can get the answer. Any of you wise guys got the answer already?
91.
91? Are you sure 91 is the answer? If we divide it by 2, we can get to 90. There'll be 1 left over. Can 3 go into 90 evenly? Think about, can 3 go into 9? Yes, so we're good, all right? What else do we have? 5. Can 5 go into 90? 5 will go into any number that ends in a what? A 0, right? So we know 5 will work. Can 6 go into 90? Think about 60. Can 6 go into 60? Yes. Can 6 go into 30? Yes. So it's going to go into 90, right? So it goes into all of those with 1 left over. And 91 divided by 7 is what? Work it out on your paper if you need to. So how many times will 7 go into 91?
13.
13 times. There you go. So it satisfies all of those requirements. So for the final answer, what is it? How many pennies are there?
91.
91 pennies. There you go. Working on least common multiples with students at Belridge Elementary School. And once again, a big thanks to the staff and students at Belridge. We do have phone tutors available until 5:30 on this final day of live broadcasting for Do the Math for this season. We have Mallory, a 3rd grade student from Lost Hills in studio. How many different smells can your nostrils smell? Is it in the hundreds?
Probably trillion.
Trillions, that's right. So you remember that long number you were working with before at the beginning of the program? All right. All right. Back to our game show, we'll call this, all right? So we have 2 more problems for you to work on. Let's take a look at the first one, add and solve. So, what do you want to do with this? There's a lot of blocks up there. What do you think we should do first?
I think we should add the 100.
Add the hundreds? Which one is those?
Those are
These?
Those are the ones that are like the big squares with a lot of blocks.
Oh, these ones. All right. So those are hundreds. Well, if these are hundreds and these are ones, what are those?
They're 10.
They're tens. All right. So how many hundreds do we have?
200.
Okay, so here's 100.
I mean 5.
Yeah, there you go. 5, because there's 2 up there, right? And then there's 3 down here, right? So that makes 500 altogether. So now what would you like to add up?
The 10s.
All right, how many tens do we have on there?
40.
4, right? So there's 4 tens, which means 40. So now what do we have so far?
I have 540.
We have 540. And then what do we do at the end?
We
We need to count these up, right? All right, why don't you count out loud for me as I point to them?
1, 2, 3, 4, 5, 6, 7, 8, 9.
All right, so how many do we have all together?
549.
549. All right, let's move on to our second one. Here we go, correct or incorrect once again. So it says 588 plus 243 is equal to 831. Now, do you think that's correct or incorrect?
Correct.
Well, that's pretty fast on that correct. Why do you think that's correct?
Because if you look at the side numbers where there's 500 plus 200, you can tell the 500 is on this side, and then if you go to the next number, which is 8, it's 80, and then the next number, which is 8, you can see it on the screen right there. And
So you're talking about these ones right here?
Yeah.
Okay. And then what?
You can see, and then on the next one, which is 243, you can tell that there's 200 on the side, 40 for the tens, and then 3 for the ones.
All right, so they wrote it down all correctly there. They broke it down. So is 500 plus 200 really 700? Is 80 plus 40 really 120? Is 8 plus 3 really 11? You're positive? Well, that's good to be sure of yourself and be positive like that, and don't let any old man mess around with you trying to get you all screwed up like that. So 588 plus 243 is 831. You say is correct? Correct it is. Mallory, a big winner once again on both of those problems. Because you have gotten 4 out of 4 correct on today's game show, you are walking away with a meal courtesy of our friends at Grillin' Burger. So congratulations on that. Have you ever been there? I've only been there one time. That's pretty good stuff over there. You like burgers? Yeah, everybody likes burgers. You can tell the old man does too, huh? All right, we have phone tutors available until 5:30. And we do have another opportunity. We're going to go out live to visit with Eddie and Devin.
Hey, thanks a lot, Mike. Back here at Merjil Steel Fabrication, talking with Eddie Merjil. We were just in the shop looking at some of the columns that are going to be installed at the Regional Occupation Center off of South Mount Vernon a little later on this year. And we wanted to come back to the Brain Trust and see where the design and the planning really takes place. And Eddie, what you rolled out for us are some of the blueprints for those columns that we were working on just outside.
Correct. Right here, we're looking at an isometric view, a 3D version of the 2 canopies.
So this is the full project that is going to be put together with the work that you're putting together.
Correct. The columns that we saw out in the shop being fabricated, as you can see, and then of course the top structures, which this particular structure is made out of I-beams, and this particular structure is made out of tube steel, hollow tube steel.
So over here, we look at all of these columns, and we usually break down even further to the blueprint of what each of those columns is comprised of.
Yes, and what we're looking at here is, you look at this single picture, and what it's going to tell you, and the easy way to manipulate this picture is, let's go to the bill of materials. The bill of materials is where you're going to find the pieces to the puzzle. It's going to dictate exactly, list what each individual part consists of. 1/2-inch plate by 7 3/8 by 7 3/8. And so then you come back to the picture, and then you find the pieces of the puzzle, and all the instructions are there on how to fabricate this, which include a lot of dimensions and part numbers and components.
One of the other things that I'm noticing too about these is, you have the locations where you're going to actually like drill the holes and make those openings for attachments. And these are broken up not just by like the full length, but as far as like parts from the middle. So like the length of this is broken up. You have 6 inches here, 6 inches here, and then maybe about 1.5 inches on either side. And that's how you are able to identify exactly where the holes should fit.
Correct. Not only where the holes are located on the component, the individual part, but where the part is located on the column. And you see that everything's referencing center lines. So everything's going to come off center line to the column. That is our datum. That is our work point.
We were talking as well about a lot of the fractions that appear on these too, and they're pretty standard in any kind of industry work. You see your halves, your fourths, your eighths, your 16ths, 32nds, sometimes even 64ths. And it's really interesting how, you really don't go too far and stray beyond those denominator or fractions in, the more hands-on engineering fields. Those end up being kind of the standards that you guys work with across all components.
Correct. And depending on whether you're with wood, steel, building a home, building a building, commercial building, whatever it is, dictates the tolerances and the tightnesses of as which specific fractions you're going to be using for your tick. Steel, of course, we're using the 16ths and the 32nds due to the fact that steel has to fit together.
Right, absolutely. Now, one of the other interesting things that we talked about as far as the math that's involved is, not just the geometry, but the trigonometry behind this. You mentioned for some of these canopies, it's not necessarily just like a flat vertical lean. There's a little bit of a tilt on some of these.
Absolutely. If these canopies, if you look at the plan view of the canopies, you're going to see that these canopies require an 1/8 inch by 12 inch fall. So this entire canopy is at a slope. That when we draw and determine the lengths of our columns have to allow for the fall, for the taper. So that's where the trig comes into place.
So each of these is going to have a slightly different height to it, and you'll have to account for that as you fabricate each of these columns.
Absolutely.
So it kind of goes against the idea that you're making 38 of the same thing. No, they all have very unique specifications to make sure that whichever one goes in that spot meets the needs necessary for that location.
Absolutely.
A lot to look at here as far as our blueprints. When we come back from our next segment, we're going to head back out there, talk a little bit about what it takes to get into the steel fabrication business, how to prepare, and what it leads to down the line. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, guys. Do remember, we have phone tutors available until 5:30. We have a very special guest, Mallory, a third-grade student, in studio with us today. How are you doing so far?
Good.
Well, you are doing pretty good because you've gotten every single one of the problems correct so far today. But right now, we're going to go to the phones. And Caitlin, how are you this afternoon?
Good. How are you?
I'm wonderful myself. So, what are you working on today?
Lateral area.
Lateral area. And what figure are you using?
A square pyramid.
All right, as soon as you're ready, let's hear the problem, and Susie will work it out with you.
Bella says the lateral area of the square pyramid is 1,224 inches square. Do you agree or disagree with Bella? Use numbers and words to support your answer. If you disagree with Bella, find the correct answer.
And what are the measurements that they give you on this square pyramid?
The sides of the square are 18 inches, and the height of the triangles are 25 inches.
All right, so I think Susie has what you guys need, so you guys can go ahead and start working this out.
So how do you find the lateral area, Caitlin?
You take all the sides, and it's surface area without the base.
Okay, excellent. So how about for one of the triangles, what would it be?
225 inches.
Okay, so how did you get 225?
I multiplied the base and the height and then divided by 2.
Okay, and why did you divide by 2? Because that's really important.
It's the formula for the area of a triangle.
Right, and one way to remember that is a triangle is only half of a rectangle. So you would have 25 by 18 would give you a rectangle. If you divide by 2, then you get the triangle. Okay, and so you got that as, whoops, used the wrong side. So you got 225, you said?
Yes.
Okay, I agree with that. And how many triangles do you have?
4.
Okay, so did you do 4 times 225?
Yes, I got 900 inches squared.
Okay, inches squared. And so do you agree that this is the correct answer?
I disagreed with Bella, so 900 is the correct answer.
Okay, so I agree with you and I disagree with her. What do you suppose how did she get 1,224?
She found the surface area, so she added 324 to 900 and got the surface area.
Okay, so she did 18 by 18 to get 324, and she added it on to the 900. So she did surface area instead of lateral area. So can you emphasize what the difference is?
Surface area is all the sides,
Plus the
and
base.
lateral area is all the everything except the base.
Excellent, that is very good.
There you
I
go.
agree.
Sounds like you've got everything you need to satisfy that requirement for your answer. And congratulations, Kaylin. You've been an excellent caller all year long on Do the Math. So
It
we're going to
was-
send
yeah.
you home one final time with a pizza from our friends at Cubby. So congratulations on that. All right, young lady, you ready to get back to work? You're sitting back, relaxing right now. All right, let's take a look. You have a line plot here. And we can see that we have days, and this is they're selling candy for a fundraiser. All right. So these are boxes of candy that they're selling on different days. So the first one says, how many boxes did he sell on day 3? So we'll go over to day 3. And how many boxes did he sell on day 3?
5.
5. Now that's easy enough to find out, right? You just count up 1, 2, 3, 4, 5. And each one represents one box. Okay? So next question. Did he sell more boxes on day 7 or day 1?
I think they sell more boxes on day 1.
On day 1? Okay, how many boxes quickly are on day 1? Can you count those?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right, and day 7?
1, 2, 3, 4.
All right, so obviously 1 is more. But how many more is it?
6.
There you go, 6. All right, let's take a look at the next one. Did he sell fewer boxes on day 9 or day 8?
Day
Day 8. How many fewer?
2.
There you go. So you get the hang of this
Pretty
pretty
fast.
quick, right? I'm throwing in these other questions on you. All right. How many days did he sell more than 8 boxes? Whoa, here now we got a lot of things to do, all right? So on day 1, did he sell more than 8 boxes? Yes. So we know that's 10. So if we look at this one, day 2, is that, how many do you think that is?
8.
That's 8, right? Now, we know that that's 8. That's not going to be more, is it? That's not more. What about day 5?
That's more.
That's more. All right. What about 6? 7? No. 8? No. 9? No. What about 10?
Yes.
Yes. How many more is that than 8?
1.
That's only 1 more, right? Okay. So the question is, how many did he sell more than 8 boxes? So we know this is more than 8. That is 8. And we know that's more than 8. And that's more than 8. So how many actually are there more than 8?
Like out of all of them?
Right, all these ones, right? So how many different days? So this counts as 1 day he sold more than 8.
2,
2 days.
3 days.
3 days. Now, why do you think somebody might put 4 days? Somebody might put 4 days. Why do you think they would put 4 days instead of 3? Because we just figured out that as 3 days is more than 8.
Because they might have put one more because number 2 is 8.
Because number 2 has 8, right? But that's the key. You have to make sure you read the question and see what they're looking for. If they wanted 8 and more, that would be fine, wouldn't it? But they were just asking for more than 8. So nicely done on that. We'll do some more questions right after this. Today we're at Belridge Elementary School, home of the Panthers, and we're here to All right, we've got some students from Belridge Elementary School, and we're going to work on some sequence of numbers and find a pattern. All right? You guys know what rain is?
Yes.
Who can best describe rain? Oh, you're all good. How would you describe rain?
Rain, it's from the ocean. It comes from the ocean. When the vapor comes, it goes into the clouds and it turns into water.
Okay. What else can we say about rain?
It's water that accumulated into the sky and made clouds. And when it's water that it filled up to a cloud too much and starts raining.
Then precipitates back to the earth, right? Okay. Here, how many of you guys have ever heard of hail? You know what hail is?
Yes.
Well, how does hail form, or what's hail?
I have seen hail, but I have never known how it does it form. But
All right, here, I'm going to read this to you guys, all right? Hailstones do this. They start in a cloud as drops of rainwater. Then they're pushed together in the atmosphere by wind, where they freeze, sometimes several times before eventually falling back to earth. All right, so they go kind of up and down in the atmosphere until they get heavy enough and they come down as hailstones. All right? You guys are going to do a hail sequence, okay? So write down these numbers, all right? 20, and then you can put a comma or a dash, all right? 10, 5, 16, 8, 4, 2, 1. Okay, now here's the sequence, all right? So you can write down the sequence if you want. If a number is even, divide it by 2. Okay, so on your paper, write even number, divide by 2. Okay, next line, odd number, times by 3, and add 1. Okay, so let's take a look at the sequence. What was the first number we had?
20.
20. Is that even or odd?
Even.
If it's an even number, what do we do?
We
Divide it by 2. If we take 20 and divide it by 2, what do we get?
10.
10. Isn't that our next number?
Yeah.
Okay, now if it's an even number, what do we do?
We divide by 2.
Divide by 2. And what do we get?
5. It's 5.
Isn't 5 the next number?
Yes.
Okay, if it's an odd number now, what do we do?
multiply by 3, then add 1.
Multiply by 3. 3 times 5 is?
15.
Add 1? 16. It's an even number. What do we do?
Divide by 2.
Divide by 2, we get?
8.
8. It's an even number. What do we do?
Divide by 2.
Divide by 2, we get 4.
Yes.
It's an even number? What do we do?
Divide by 2.
Divide by 2, and what do you get?
2.
It's still an even number. What do we do?
Divide by 2.
Divided by 2, what do we get?
1.
We're all the way down to 1. All right? I want you to pick a number, all right, between 12 and 30 and write it on your paper. So start over on the left-hand side. So write a number between 12 and 30. Okay? Write down any number. You've got 3 more seconds to do it. 1, 2, 3. Now, I want you to do the hail sequence, the hailstone sequence, all right? So, your number is 30. So what do you have to do if it's an even number?
Divide by 2.
Then do it and keep going. You have 30 also? 26, ooh, good. Odd number, 25, 25. A lot of 30s and 25s. All right. Now, if you have 25, what are you supposed to do? It's an odd number.
Times it by 3 and add 1.
Times it by 3 and add 1. So what's 25 times 3?
25 times 3.
75, and add 1, 76. So your next number is 76, right? So keep going. Everybody's got their own thing. Let's see who can get to 1 by doing the hailstone sequence. So keep working. Some of you are going to take a little bit of time, but that is working with a sequence, the hailstone sequence, with students at Belridge Elementary School.
I'm gonna wear this shirt for Corona film.
And since today is the final day of live broadcasting, big thanks to all of the staff in schools that we were able to visit during the entire year. We made our way throughout Kern County, as well as San Luis Obispo County, as well as Santa Barbara County. So we had an opportunity to visit a lot of schools in a lot of counties. So we just want to say once again, thank you to all of the schools that we were able to go out and visit. We do have phone tutors available until 5:30 this afternoon. We have Mallory, a third grade student from Lost Hills, in studio with us. You ready? All right, these are the last few problems we're going to do, but they're not going to be easy. Are you ready? Okay, let's go ahead and take a look at the screen right here. Now, we see some figures, and there are some that are light and some are dark. What's up with that, first of all?
Well, the ones that are dark are shaded and the ones that are light are not shaded.
Okay, so you have some that are shaded and some that are not. Now, take a look at number one. It says they want a fraction. So number one, what would the fraction be for that?
1/2.
1/2. So that would be 1/2, correct?
Mm-hmm.
All right. What about number two?
That would be 1/3.
1/3. Now, how do you know it's 1/3?
Because there are 3 all together, but 1 is shaded.
Right, so we can see there are 3 parts, right? And only 1 is shaded, so it's 1 out of 3. Now, are you familiar with the terminology for what the number on top is called and the number on the bottom? Do you know what those are called? What is, you know?
The bottom is denominator and the top is numerator.
Wow.
Excellent, numerator
Yes.
and denominator,
Those are
nicely
big
done.
words.
All right, well, you know what? We're gonna move on. Let's go down and I think the circles are easier for you. So I'm gonna go on to the rectangles. You good with that? All right, we'll see if we can, what about this one?
That is 1/4.
1/4. All right, let's move on. Oh, here we go. All right, Hotshot, what do you think about this one?
That one is 3/5.
Now, are you counting the shaded ones first or the whole thing first?
I counted the whole thing first.
Why do you
Very
do
good.
that?
So I know the total number.
Right, that's the best thing to do is, right, figure out the total number first, the whole part, right, and then figure out how many are going to be taken away from that. All right, let's go down and let me try number 42.
That is 6/10.
6/10, very good. Nicely done. Every single one of those correct. And you know what? We'll see if we can stump Mallory with another problem, but we'll do it right after we have our last opportunity to learn a little bit more about steel fabrication.
Hey, thanks a lot, Mike. Back here at Merjil Steel Fabrication with owner Eddie Merjil. Ed, we were talking a little bit about kind of the pathway to get to where we are today. So how did you get started in steel fabrication, and how did ultimately your story bring you to this point?
Well, actually, when I was in high school, I was actually part of the rock program, in the welding program. And so for a year and a half, I was being bussed out, learning how to weld. When I came out of high school, I got a welding job, and it was great, making a comfortable living, enjoying it, the skill, I had it. And then I realized that, hey, I need a little bit more background, education background, mainly mathematics. So I went back to school. I went to BC and started taking classes at night and continued to work, and took that to where we are today.
So you had a point where you had the skill that you were trained in and you picked up and you were drawn to it, and you found that you had some skill with that, and then you developed that further to understand the craft more deeply to ultimately take it to the point where you could own your own shop.
Correct, absolutely. Because needless to say that we use math in here every day. Every one of my employees uses math in here every day. Basic dimensions, basic configurations, slope, fall, geometry, working with shapes, and so on and so forth.
So beyond geometry, what components of math would you recommend if students are starting to explore different pathways in high school? What skills would you recommend that they start to really refine before getting into this field?
If you want to do anything in construction, from one level, from the entry level to running your own company, learn how to read one of these. It's a measuring tape. Learn your fractions, know your fractions. Every trade every construction trade utilize this as the #1 tool. It's the first tool they hand you when you walk in the door. Learn your fractions, understand it.
And those fractions break down and decompose so many different ways, and it's just a matter of that number sense that students really start to develop as early as 3rd grade. So if you have that feel, or if that's a skill that you really want to continue to refine, you know, there's tools in the real world that allow you to do that. But, you know, one of the things about math is that all math is real world math. And the more that you explore it and the more that you find it, the deeper understanding you'll have with that. And so, what would you say is kind of your proudest achievement working with the company? What is the thing you're most proud of working in this field?
Working in this field with being an owner of my own company and having a staff that we're a team. That together, not only do we produce a product and we finish the product, we install the product, so we take pride in having that product out there. Our employees, like I said, we're a team. And I'm proud to say that we have a corporation here, a company that can employ staff and keep a steady job, keep them in a career.
So Eddie, what kind of projects can we expect to see your work attached to in the next coming months?
Oh, commercial buildings throughout town. And what I mean by commercial is all the strip malls, Panama and Ash, off of Olive Drive. We're actually doing a project up at Bakersfield College, an expansion of one of the buildings. Currently we're working on an expansion at the ROC program, the construction trades and veterinary program.
You're all around town, Eddie. And it's good to come in and see the work firsthand, as we do with all of the hosts that come by and allow us to come through the doors and see how things go. We want to thank you and award you with our commemorative honorary Do the Math tile plaque.
Oh, all right. It's going up on the wall.
Let's get there, Eddie. Thank you very much for having us by. Folks, it's our last episode of Do the Math for the season, and every chance we get to visit our wonderful community partners and our school sites, we're able to make a deeper connection with our community and the world of math around us so that you at home have an opportunity to find your own pathway. Mike, for the last time this year, we're going to send it right back to the studio. Take it away.
All right, thanks for that, and thanks to Eddie, the man of steel today, right? So thanks to Eddie out there. Hey, we do have phone tutors available until 5:30 this afternoon. Mallory in studio. What was the last problem that we looked at? It was number 42, and what did you say that was?
6/10.
6/10. So we're going to go a little bit further now. If we wanted to simplify that and get an equivalent fraction, what would that be? So if we have 6 and 10, what goes into 6 and 10?
You were saying what you can count by to get to 6
Right,
and 10.
if we have 6 and 10, what can we divide by both of those?
2.
Right, so 6 divided by 2 is?
3.
And 10 divided by 2 is?
5.
There you go, so 3/5. Nicely done, Mallory. Thanks for coming in. Phone tutors here until 5:30. Been wonderful season again with everybody involved, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.